Today you're going to be taking video notes on 6.4, Proving Congruent Angles and Proportional Sides. As you watch the video, pause as you need to, and raise your hand when you have a question. First, let's review what we learned yesterday. In order to prove that two shapes are similar, you need to know two things. First, you need to know that all corresponding angles are congruent. The second thing you need to know or find is that all corresponding sides are proportional. Now, as we learned yesterday, the angles aren't always marked congruent. Sometimes there's things we're going to have to remember from last year that will help us show that the angles are congruent. So let's first look at ways to prove angles congruent. First is the definition of congruence. The definition says, if two angles are the same measure, then they are congruent. In this picture here, angle M and angle B are both marked 50 degrees, so I know that angle M is congruent to angle B. Another way to prove angles are congruent is vertical angles. Anytime you see vertical angles, you know that they are congruent. Vertical angles make an X shape with each other. So in this picture, it's the two angles here at R. Now when I name these angles, I want to use three letters so I know which one I'm talking about. So the one on the left-hand side here, I'll name angle QRS. And because it's vertical, I can say that it's congruent to angle TRB. A third way to prove angles congruent is reflexive. And all reflexive means is that every angle is congruent to itself. Now this might sound a little confusing, but if we look at this picture, we have a small triangle with a bigger triangle on top of it. What you hopefully noticed when I outlined each of these triangles is that I traced over angle D twice. So I know that angle D is congruent to angle D. Let's work through some more ways to prove angles congruent. Next, we have the third angle theorem. This says if two corresponding angles of a triangle are congruent, then so is the third angle. I can prove this by simply finding the missing angle. 64 plus 46 is 110. If I subtract that from 180, I can find that my missing angle is 70. If I did the same thing here, 64 plus 46 is 110 minus 180 tells me my missing angle is also 70. So just two angles the same tells you that that last angle is also the same. Another important thing to remember from last year is parallel lines in a transversal. There's three different angle relationships that are congruent when you have parallel lines in a transversal. The first, corresponding angles are congruent. Corresponding angles, Corresponding angles are angles in the same spot. So for example, If I look at this picture, 1 is in the top left, and so is angle 5. So angle 1 is congruent to angle 5. Another relationship that you learned last year, alternate exterior angles are congruent. Those are on alternate or opposite sides of the transversal and on the exterior of the parallel lines. For example, 2 and 7. One final relationship to remember with parallel lines in a transversal is alternate interior angles are congruent. Alternate interior angles are on alternate or opposite sides of the transversal and inside the parallel lines. For example, angle 3 is congruent to angle 6. Of these, the one you'll see the most is corresponding angles. The last one, which we saw happening yesterday, is an isosceles triangle. In an isosceles triangle, you have two congruent sides and two congruent angles. So for example, if these two sides are congruent, then the angles opposite them are congruent. I can reverse that. Let's say I start with these two angles congruent. That would tell me that the two sides across from them are also congruent. Next, we're going to look at ways to prove sides proportional. This is something you have not seen in the past. The first is the side splitter theorem, and it says if a line is parallel to one side of a triangle and intersects the other side, it divides the sides into segments of proportional length. So I'm going to write a proportion. First, let's look at the top side. It splits into AB and BC. So that's going to be my first ratio in my proportion. I'm going to set that equal to, now I'm going to make sure I start at the top again, AE and ED. I can use these proportions if I want to prove sides proportional or if I wanted to set up a proportion and solve for a variable. So for example here, I could write a proportion 12 over y equals 10 over 6. Pause the video and solve for y. If you've solved correctly, you should get y equals 7.2. If not, check your math and raise your hand. The final theorem for today is the angle bisector theorem. And this says if a ray bisects an angle, it divides the opposite side into two segments that are proportional to the two sides of the triangle. So here, this angle bisector splits it into BD and DC. That's going to be one side of my proportion. The other side of my proportion is going to be the other sides of the triangle. So BD matches up with the side that it touches, AB, and DC matches up with the side that it touches, AC. Let's try and do this in an example. So let's say we have an angle bisector here. We're going to look at the two pieces it splits, here and here. Now the small piece here isn't labeled, but if I take 66 and I take away what the other piece is labeled 30, I know that other small piece is 36. So that's going to be one side of my proportion, 36 over 30. The other side of my proportion is going to be the other sides of my triangle. 24 matches up with 36, and I don't know the other side of my triangle, so I'll call it x. Pause the video and solve for x. If you've solved correctly, you should get x equals 20. What you're going to do on the rest of this sheet now is practice. So first, name the congruent angles. Then you're going to solve for missing variables using some of the things we learned above, maybe vertical angles, maybe our proportional properties. When you think all of your answers are correct or you're stuck, raise your hand and ask. Once you've gotten all your answers checked, you can begin your homework, which is a review of sections 6.1 to 6.4.